Welcome back. Let's dig a little deeper. What does the Node.js runtime over here include beyond just the V8 engine? What do the internals of Node look like so we can better understand what's going on behind the scenes? Remember, V8 here is what lets Node run JavaScript. But there's so much more to Node than just the ability to run pure JavaScript. There's this entire environment, this entire runtime that runs outside the browser, that lets us do things that aren't part of the JavaScript programming language out of the box. If we run JavaScript code like 2+2 or concatenating two strings like woohoo, in Node, V8 will know exactly how to execute that code and give us the result on our computer. But what happens when we try to get the arguments passed to our Node process? Or when we try to read and write files on our system here? All these things that Node can do that our browser can't. For that, let's take a look inside of the Node.js runtime. We've already seen that we have the V8 engine, which is what allows us to run basic JavaScript code like 2+2. But also part of Node are our Node.js APIs, or additional functions that allow us to do things like talk to the file system to read files, and make HTTP requests, or look up paths on our computer for files that we might want to read and write. And even things like the crypto functionality, which has some built-in code that allows us to make our Node programs more secure. For example, by encrypting some data for us. Now, when V8 sees some code that uses these features, it'll say, okay, I need some help to execute this. And it'll call the corresponding functionality in our Node.js APIs. Some of this is written in JavaScript, but also in lower-level languages. Languages that are more like the machine code that the hardware on your computer speaks, like C and C++. And that's where these Node.js bindings come in. These bindings are what lets your JavaScript code call functionality that's implemented in C and C++, which have things like really highly optimized and tested code to encrypt your data, or to make calls to your file system, reading and writing files regardless of which operating system you're on. So for much of their functionality, the Node APIs will call into these C++ Node.js bindings. Now, the actual implementation of some of this core functionality, like working with files or the HTTP protocol, lives in what we call libuv, with this fantastical creature over here as its logo. libuv and V8 are the two most important internal components of Node.js. That's because libuv deals with input and output tasks. It's this highly optimized library of code written in the C programming language that deals with input-output tasks that Node can delegate to other parts of your operating system. This is like your boss telling you to create a 5-page report on the strengths of Node.js, where he's delegating that task to you. Probably because he knows you have the time and expertise to do it. Just like that boss, What this means for Node.js is that, say you're downloading a web page, and that download request takes 30 seconds. Well, a download request is input that's asking for output, for a response from the web server. So what's going to happen is we'll make a request in JavaScript using the HTTP module, a function from this HTTP Node.js API, and through the Node.js bindings, Node will pass that task on to libuv, which will just tell your operating system, okay, here are the things that I need, say the contents of a web page, and the operating system will go off and perform those tasks. So we've delegated that task to the operating system, and our Node program, our JavaScript, doesn't have to wait around for the response. Node just says, okay, operating system, let me know when my task is complete, and I'll get right back on it as soon as I can. This is called asynchronous I/O, or asynchronous input-output. It's what Node is best at, and it's something that we're going to learn a lot more about in the next coming videos, because it's so important. Nearly all of the code that we write in Node involves some form of asynchronous I/O. This includes functionality provided by libuv, like working with your file system and making requests over the network, over the internet. Whether you're on Windows, Mac OS, or Linux. You see, part of the challenge of working with all of these different operating systems, particularly when you're working with lower level languages like C and C++, is that each of them accomplishes the same thing differently. The way you open a file on Windows versus Mac OS is actually quite different, even though you're accomplishing the same thing at the end of the day. And that's where the beauty of libuv shines. It abstracts away all of these specific ways of reading a file, for example, so that Node will work on any system, on any platform. It does this by implementing the functionality in libuv and exposing it to this higher level layer, which is then translated back to our JavaScript. Using what we've just learned, we can adjust our bird's eye view of what Node does, replacing our old model with a new, more accurate model, where our JavaScript goes into this Node.js process, not just with V8, but with the additional components we just talked about, which process our input and send it back to the user to do something. All right, so we have this diagram in front of us. We've talked about things like implementation and bindings. But what exactly this means for us and how each piece connects to each other probably doesn't seem fully clear to you yet. We've been talking about the internals of Node, but let's actually apply this theory. That way we can better understand these deep internal workings of Node. For that, I'll see you in the next video.